Hey everybody, welcome back. This is part 2 of our series on PCB design. Stick around as we build up this breadboard circuit in preparation for laying out our own printed circuit board that does the same thing. But first, here's 20 seconds from our sponsor. I'm going to begin by removing the wires that we have here, and then I'm going to load up a program that I really like to use when I'm doing my project called Fritzing. And you're going to appreciate how I'm able to recreate what's here on the breadboard right on the screen on a virtual breadboard. So let's pull these wires, just get them out of the way, and we'll be putting wires back. But first, let's launch Fritzing. Now it'll become really apparent as we work along here why I really like working with Fritzing. I've got it loaded up here as a fresh document. We haven't done any work yet at all. You have multiple views here. We're looking at the breadboard view right now. There's a schematic view as well, which is empty. There's a PCB view, which we're going to be using a lot. It's empty right now. We're going to go back and we're going to recreate on the screen what we're actually doing down here on this board. In order to do that, let's drag some parts over here. Obviously, we're going to need our 2 shift registers, and I've already found these parts and stored them in my little parts bin. So I'm going to drag one of them out. We'll just position it on the board right about there. And then we'll need a second one. So I'll just drag it out as well. We'll set it there. I could not find a part to represent our 4-digit panel, so that's not going to matter. I decided it's simple enough. What we need to know is where the pins are. So let's just take a header, and we'll let a header represent 6 of the 12 pins on that panel. Well, this one has only 3 pins on it, so down in this corner I'm going to change it to a 6-pin header, just like that, and we'll drag it down and position it right here on the board. And then I want to duplicate it, so I'll go in here and say that I would like to duplicate, which I could do with a Control D, but there's now a second one for the other half of that panel, and we'll put it in here. That's the same spacing that I have over here in the real world. We'll need 2 more of those, but before we do that, we should duplicate our breadboard. Again, Control D, and now there's a second one here. Let's see, I can move it up, just set it right there, line it up. So we now have 2 breadboards just like we do in the real world. I can back off and make it zoom back a little bit, see it better there. So we'll duplicate our header one more time with a Control D, and then I want to move that into this position here, and 1 more of those. We'll duplicate that again, and it's going to go all the way up to, I believe it's there. That all looks good. So those headers then will represent the 12 pins on each of the 2 display panels. We're going to need some current limiting resistors, so I'm going to bring this resistor here down there. It says over here that it's a 220 ohm resistor. I'm going to change that to a 470 ohm resistor. I'm going to rotate that guy, and then I'm going to just position him in here, maybe put it there. Now I'll duplicate him again using Control D on the keyboard. There is a second one. So we have our 8 current limiting resistors. They're all here. And so we have now all of our parts. Just to give you a little sneak preview, let me click on the PCB tab over here and look what's going on here. All of our parts are over here as well. So it'll be interesting to see. Looks like all of our resistors are piled up on top of each other here. Well, now it's drawing lines. We don't want to draw lines, but let's go back to the breadboard view. This is going to match the real world, but this will be our virtual breadboard. I haven't put in the 5 volts yet coming from the Arduino. Oh look, we've got this guy off the edge. Let's bring him in here. He goes right about there. And we'll put that one in there. Much better. That looks much better. We'll be able to wire things better from that now. One of the neat things about fritzing is that when we take a part like this and we put our pointer on to the pin, it tells us what that pin is. And that pin says it's VCC. This is pin 16. It's going to be our voltage. We have this already hooked up on our board, but I'll go ahead and I'm going to draw a line in here. This is a wire that will be our 5 volts that'll go to this pin there. I'm going to do the same thing for the same pin on the other board. And I've got to do ground, and that's this guy right here. It says so. So let's pull ground down here, but let's not make it red. We'll change the wire color to black for ground, and then another one right here. It looks like we'll do that one. It will be black as well. So these wires right here match up with the ones you see over here on the breadboard. They're different colors on the breadboard, but they match right there. And look at this. If I click on anywhere here on the ground rail, it shows you that ground is going up to those pins 8 there. And if I click on the 5 volt rail, you don't see it going. So we're going to need to link these rails. So I'm going to run a wire from here to there. That will be a link for us. We'll make it red because it's the 5 volts, and I'll just kind of bend it out of the way right there. So now when I click down here, you'll see the 5 volts is going in there just like that. Everything is fine. Now obviously, when I brought the voltage down to that second chip, I brought it to the wrong pin. But I catch this error later and correct it. Our virtual world and our real world are starting to match up with each other. Now we know from our drawing here of our pin that the output A is over here. It's pin 15. And we know from our drawing that we figured out that A is going to be the second pin on the top row here. We'll just take a jumper here. We need to go from a resistor, let's take this one, to this pin right here, and I have to tilt the board to see it, but it is the second one right there, and I've got it in. So we put a green wire right there. Back on the virtual breadboard, I'm just going to show this link, change the color to green to match our wire there. So we've run a wire from here to there. Then the other side of that needs to go to the pin that's going to be A on our shift register. That was this guy right here, the second one. So we will grab a wire again. This one is yellow. I'll plug it into here, and it comes over and plugs in to the second to the last pin there, and that guy. Back to the virtual board. I'm going to run a line from here to there. Put it right there, I guess. We will make it yellow. And just make it a loop of a wire there. Goes from there like that. That's the second one. So our virtual world and our real world are starting to match here. We'll do one more of these, and then I'm going to skip ahead for you so you don't have to watch me plug wires and draw wires through the whole thing. So let's just do the next one. The next one is the B segment. It belongs right here. And so let's see, we will run a wire from the second current limiting resistor to here. And what color's coming up next? I've got a blue one. So I'll put it in here on the board. We got a blue one there, and it's going to this pin right there. Oh no, that's not right. It goes to the last one over here. Goes to this guy. That's our segment B. We can change that. So instead of taking it from here, we will take it over to there. What color did we make it? Blue? Alright. It'll be a blue wire. And I'll put it right there. And that takes care of our B. B is going to go to this pin right here. We'll grab another wire. Oh, it's another blue one. We'll take it from here, blue, over to this pin right there on the shift register. So draw it from here to there, and it's also blue, so there, we've got that one done. So I'll stop recording right now and I'll do some more wires and put them on here. Okay, I'll be back in a few minutes. Well, we're back, and if you look here, you can see we've really built up a rat's nest of wires and stuff on our project here as I've been putting all these jumpers in. And if we switch over and look at the Fritzing version, you can see that there's plenty of wires there. We have a virtual version of our rat's nest, this snarled up bunch of wires. One of the advantages to using the virtual breadboard here in Fritzing is that it gives us an opportunity to make sure that these snarly wires are all going to the right place. For example, if I come over here and I look at the pin that's supposed to go to the A segment, this pin right here, if I click on this connection, you'll see these yellow dots appear right above the chip. But then you look over on this side, you'll see that we've got the connection going to this first resistor on the right. Now if I come over here and I click on the resistor, we can see that the other connection goes over here to the second pin on our top connector for the panel. Let's take a look now at our notes over here, and we'll see that this second one does indeed go to A, segment A. We know that that connection is correct. And let's show you one more. This is where our B connection is supposed to be. I'll click here. You can see over by the resistors, it's connected to the second resistor on the right. We go over here, we click on the other end of that resistor, and we'll see that this blue lead comes up to the last pin on the top row of connectors. Now, take a look again at our notes, and sure enough, the last one on the top row is the letter B. And I can do that with each of the segments and all 8 of the data pins on my shift register to verify that they are all going to the right place. Now I apologize for the changing in the lighting here. Mother Nature is doing a lot of different things outside my window today, and that's changing the lighting here in the ham shack. So bear with me. So sometimes I'm bright, sometimes I'm dark. Well, I guess I don't know how bright I am, but you know what I mean. So let's take a look again down here at our board. Now we've talked about how there's 8 wires going to this panel, and each wire basically is driving an individual segment in our digit, but there's 4 digits, and this works because these segments, this A segment right here and this A segment here and that one there and that one there, are all tied together. And so there's one common thing there. It's the cathode that we change to determine which digit gets lit up. But that's only half of the digits we plan on using. We've got another panel up here, and we want to drive those as well. To do that, it's really quite simple. All we need to do is run one wire from the same pin on this panel to that panel up there, and then we will have 8 digits with their segments tied together instead of only 4. That's what we'll do next. So I'll need to do that in both the real world and the virtual world, and then I'll get back to you. There we go, and I'll put it in over here. This is the last connection. With that done, let's hook up some power and see what we've learned. Okay, I guess we'll start by adding a ground here to one of our cathode pins. Remember, we've got 6 pins across the bottom, and the last one was a cathode. The others were all anodes. So I'll just ground this one cathode right there. And then we'll do the same thing with the cathode at the other end there. So the both displays will light up the same cathode on both displays. So we've got those both grounded, and now I just need to get some 5 volts here. Now you'll notice that we have a lot of connections coming in right into this area right here. This is our shift register, and there are 8 pins that are coming out of our shift register that drive the segments of our displays. We've got segment A over here on pin 15, and then B is on 1, C on 2, and it goes right on down clear to H, which is our decimal point. And those are all these wires along here. And we can talk later when we're talking about the software about how we're going to run this shift register. While we're working with the hardware, we don't need to worry about it right now. But I can bring 5 volts in from our rail and light up segments over here, and we should be able to just go right around the ring here and light up everything A through H. A, of course, is the one that's on the back side over here, and if I put that in there, our A segments light up. And notice, of course, that it lights up on both panels because all of these wires that we just hooked in here have them tied together. So that's segment A. Now we try B. That's good. C, D, E, F, the crossbar, which is G, and finally our decimal point right there. We have succeeded in wiring all the anodes. Now let's start thinking about the cathodes. Okay, we pretty much maxed out this shift register. The shift register has 8 outputs, and we've used them all for the 7 segments on our digital display here, and the decimal point making the 8th one. So that takes care of this shift register right here. Now we need to hook up 8 cathodes, and that's what this shift register is going to do. We have another 8 outputs on this register that we'll connect these cathodes to. So let's do just a little bit of planning here. Get this out of the way. And here's our shift register right here. We have our cathodes numbered here, 1, 2, 3, and 4. I'll just transpose those numbers over onto this sheet. We'll use the first output, QA, to be cathode number 1. And we'll go cathode 2, 3, and 4 right there. Now, when we go to the other set of connections up there, we'll just kind of repeat these over. We've got 1, 2, 3, 4 here. So on the upper panel, we'll put cathode 5 in the same position we had cathode 1 in the lower one. And so we'll put 6 here, we'll put 7 there, and we'll put 8 there. So they match up like that. Going back to our diagram of the shift register itself, that means we'll put cathode 5 here, 6 there, 7 here, and the last one, number 8, will go in that position. And you see, we're going to use all of the outputs on the second register. So just think about it. That's another 8 wires. Are you ready for this? Okay, I've got my plan laid out here. We're going to grab the first cathode, which is pin number 1 on the top of this board. So I got to get in here and find my way into this thing. And that will come over here to this pin on our shift register right there. We kind of expected that. I think I'll take the power off the board while I'm doing this because odd things will be lighting up. And speaking of more wires, I'm running out of wires here, but I'll show you what I like to do is, have you seen these guys? You can order them on eBay. It's kind of a DuPont connector here. It's a ribbon cable. It actually has 40 connectors on it, and you can get them with male ends on both ends, female fittings on both ends, or you can get them with a male on one side and a female on the other side, and you just pull off however many you need to make connection. I've been pulling these off over here. If you need a connector, I just, like this black one right here, I just peel it off right like that, and then I've got the wire that I need to hook this next one up. So my notes say that it's the third one from the end over here on the top row is cathode number 2. So I'm coming in here, there's 1, 2, 3, tight fit in there, and it comes around and plugs into that one there. And I will go ahead and do these on the Fritzing end too, but I'm going to go ahead. This is easy to do because it just makes sense. I'll peel another one of these off, and we want number 3, which is right next to it. I got to get in there. And look at that. All of our cathodes are connected. This is really coming together now. So give me a few more minutes. I'm going to go back into Fritzing and repeat everything you just saw me do here in the real world. I'll match it in Fritzing so that our circuit board stuff will be ready to go, and I'll be back. Check this out. I took a photograph of this rat's nest of all these wires and connections going every which direction, and it's amazing that this is going to even work. But it's an example of how valuable companies like JLC PCB are to us as hobbyists, that we have now the tools we need to create printed circuit boards so that a mess like this doesn't have to limit what we can do. And over here, this is the same mess on our Fritzing screen right here. Zoom back out a little bit so you can see it there. It's a bunch of wires, but because we're in Fritzing, we have the capability of checking that things are going where we expect them to go by simply clicking on these dots and seeing where they end up on there. Before we start hooking this project up to an Arduino, we need to talk about the rest of the pins on our shift registers. We've already used the first 8 pins for our digital outputs. We've used pins 15 and 16 as well. But what's with these other pins, this 9, 10, 11, 12, 13, and 14? What are those pins anyway? The cool thing about using these shift registers is that even though we need to control 16 different outputs, we can manage the whole thing with only 3 wires from our Arduino. There's a data line, a clock line, and a latch. Take a look at this pin 13. This is our output enabled pin. And you see that line across the top of it? That tells us that the logic is reversed on this pin. Normally, if you want to turn something on, we run the pin high. We would put 5 volts on that. But the line above it says, no, this is logic level low. So if we want to enable this pin, it has to go to ground. So we are going to ground this pin permanently. We'll do it to both of our shift registers. We'll connect both pins 13 directly to ground. Take a look at pin 10. This is our shift register clear pin. It also has a line above it. And that means that whenever this pin goes low, it will just clear out our whole shift register. That's something we don't ever want to do. So we're just going to simply take this pin and connect it directly to 5 volts. We'll do it to both chips. This time let's start with the Fritzing side of things. If I connect here, we can see that the ground is coming in to those pins on our chips. Now just give me a minute or two while I'll hook those same wires up to the printed circuit board, and I'll speed things up so you don't have to wait so long. There, those are ready to go. Now it's time to start talking about hooking this thing up to an Arduino. And can you believe this? Fritzing actually gives us an Arduino that we can use here. Let me scroll back so we have some space here. And I'm just going to grab this little guy right out here. Look at there. Does that look familiar? We've got an Arduino. Let's just slide this thing up here where we can start hooking a few wires up to it as well. I'm going to get my 5 volts and ground right off of this board right here. So that end is good to go. Now we're going to need to bring 3 lines from our Arduino over to our circuit to run these registers. I'm not going to go directly to the registers because I'm going to need a way to hook this up when we actually get into the real world and we're running this with our printed circuit board. So I'm going to bring a header over here to set this up, and I'm going to make that header be 5 pins instead of only 3. We'll actually put our 5 volts and ground onto this header, but we'll also put the 3 data lines on there, and I'm going to do 2 of them. And I like to do this because when we get into the real world, we don't. Where did it put that guy? Here it is. I found it hiding from me over here on the Arduino. We'll just park him up there for now. We'll talk about what we're going to do with that one in a bit later. But now we need to bring our data from the Arduino over to these shift registers. And the first one that we're going to bring in is the latch pin. I want 2 sets of these. I'm going to just take and connect these across. And the reason I'm doing this is because I never know for sure what part of the board I'm going to want to run my wires to. So I'm going to put headers on both ends of my board that are just duplicates of each other. These headers will be at opposite ends of the PCB, and they will give me a choice on which side I hook my Arduino up to, or whatever microcontroller I plan on using. Latch pin needs to come down to pin 12 on our shift register. I'll double check that there. Yep, it says it's 12. It's our latch pin, and I'll pick a color for that. Wired. I'll do the same in the real world, and we're just about ready to hook up some software. Well, all of that is a little bit tedious, and I really commend you for sticking through this far if you're still here. All of those connections that we were able to make in that virtual breadboard world will be there when we need to put together our printed circuit board. In the next video in this series, we'll take a little side trip and look at the software and talk about the sketch that's going to actually run this thing and make numbers appear on our panels. I will look forward to seeing you then. And hey, don't forget to subscribe, like, and share.